For decades, scientists, communities, and ordinary people awaited feedback from the universe, and now it's finally here. Did we actually get an informative signal from space? And this signal isn't in the radio range like the others. It's optical, which means that with the right equipment, anyone can see it. Thanks to which international program did we detect the unusual message coming from a distant star? Search for extraterrestrial intelligence. The search conglomerate, representing a collection of several scientific projects, since 1960 focused on monitoring the universe for signs of extraterrestrial intelligence, helped with this. The methods of this program are diverse, and they are not limited to radio monitoring. For example, there are so-called optical search for extraterrestrial intelligence programs, in particular the laser search for extraterrestrial intelligence program, which detects flashes of light and laser pulses using a special optical system. And just recently, in January 2025, a star with the codename Henry Draper 12051 behaved in a rather unusual way. The signal was detected by Richard Stinton, a former National Aeronautics and Space Administration scientist. The star is located 135 light-years from Earth and, according to its spectral class, is similar to the Sun. It's a dwarf with approximately the same mass and radius as the Sun, with the only difference being that it's a bit cooler than our star. Thus, the star located in the constellation Cetus was not remarkable in any way, until the beginning of 2025 when it started emitting strange signals. When they were detected, the equipment recorded 2 optical pulses with a difference of 0.4 seconds, and the duration of the signals was approximately 0.2 seconds. But in that short time, the brightness of the star decreased by 1/3. That's a significant indicator that can't be caused by random reasons. This is what the signal looked like. What is the nature of these pulses? If we rule out light diffraction from some asteroid or artificial Earth satellite, as well as gravitational waves affecting the star in question, then only one option remains. Technosignatures, that is, possible evidence of extraterrestrial intelligence. Unlike biosignatures, which are represented by certain molecules, for example, oxygen and other biomarkers, technosignatures indicate the activity of an intellectually advanced civilization, one advanced enough to manifest itself through physical structures, electromagnetic signals, and other technology. So, the star Henry Draper 12051 emitted just such a signal, a laser pulse that might be used for interstellar communication. Can natural causes explain this signal's appearance? Absolutely not. Since terrestrial interference is ruled out, only stellar processes remain, which could potentially occur on the celestial body itself. But this option is unlikely since such impulses do not correspond to either flares or pulsations, which follow completely different laws. Moreover, most likely, the source detected by the search for extraterrestrial intelligence equipment is closer to our planet than the specified star. Judge for yourself. Are stars with a diameter of more than 1 million kilometers really capable of instantaneous modulation? Is it possible to instantly reverse the explosion of a neutron bomb? Information about the strange optical signal was published in the Acta Astronautica. A more detailed study of this phenomenon is planned for the current year, 2025, using several telescopes. The data from these telescopes will then be synchronized and analyzed. Currently, the Gaia telescope confirms that Henry Draper 125d is an ordinary star, not a runaway, or a star moving at extremely high speeds. Against this background, its behavior looks even stranger. But has the search for extraterrestrial intelligence project really not detected a single signal suspected to be extraterrestrial since the middle of the last century. All we have left is to settle for the famous wow. That's the thing. Before that, 2 optical pulses were detected coming from different stars in various parts of space, and they were absolutely identical in terms of their characteristics. This also leads to some conclusions. In 2019, once again thanks to the laser search for extraterrestrial intelligence optical system, short-term pulsations lasting about 0.2 seconds were detected, during which the brightness of the star decreased by a quarter. The nature of the phenomenon also remained unexplained. First of all, the work of the optical equipment that studies the phenomenon, especially since it is not a single occurrence, is aimed at ruling out terrestrial or near-Earth causes for the appearance of the signal. What kind of star revealed itself in this way? Henry Draper, 217,014, also known as 51. Pegasus is located 50 light-years from Earth, and like the previous object, it is also very similar to the Sun, only a bit more massive and hotter. Near the star, the exoplanet 51 Pegasi b was found, discovered in 1995 by Didier Queloz and Michel Mayor, for which they later received the Nobel Prize. The planet most likely belongs to the hot Jupiters and is located very close to its parent star, so it completes one orbit around the star in just 4 days. But of course, the planet's transit has absolutely nothing to do with the impulse we're discussing. It's far too insignificant an object to cause such an effect. Are you familiar with the saying, "Third time's the charm"? Now is the perfect time to remember it. Because in May 2023, another strange impulse was detected coming from the distant star. Undoubtedly, this is a solid basis for study because it's impossible to ignore such signals after they've been detected 3 times. So it's the same Richard Stenley, a former employee of the National Aeronautics and Space Administration Space Agency. As part of the Search for Extraterrestrial Intelligence program, he recorded an identical double pulse, separated by a 0.4-second interval lasting 0.2 seconds, meaning the signal's characteristics were once again exactly the same. The scientists spent more than 1,500 hours observing, but found nothing similar. The pulses turned out to be unique. Even without an astronomical education, it's clear that the luminosity of a huge star with a diameter of 1,000,000 can't be adjusted with a dimmer to make it dimmer. It's like stopping a speeding locomotive in a second. By the way, did you know that the developers of the Search for Extraterrestrial Intelligence project have a sense of humor? In May 2023, the interplanetary station ExoMars, which is in orbit around the red planet, transmitted a signal containing a message that resembled something extraterrestrial. This was initiated by the Search for Extraterrestrial Intelligence Institute, with the nonprofit project developed in Mountain View, California. Naturally, Earth's astronomical observatories picked up this signal, and work began to heat up. Dozens of scientists, from professionals to amateurs, set out to solve the puzzle. And by the end of October, the first results appeared. After dozens of computer simulations and mathematical calculations, father and daughter Ken and Kelly Chaffin deciphered the fake alien message. They interpreted the cosmic puzzle as a hint at the 5 amino acids involved in the creation of life. Here's what they came up with. Subtitles, Dimitrov. What conclusions can be drawn from this experiment? First of all, the signal from Mars orbit is much stronger due to the relatively close distance than the one that could come to us from the far depths of space. Even though several telescopes detected the impulse, only one identified it as extraterrestrial. So even if we receive a greeting from space, it's not certain that we'll be able to interpret it correctly. Secondly, decoding such a signal could take years, and that doesn't guarantee we'll fully understand it. We'll probably only be able to guess who wanted to tell humanity something and what it was about. Besides optical ones, what other signals from deep space has humanity received relatively recently? The news concerns ASCAR J1832-0911, a mysterious, unexplored object that breaks all known astrophysical laws, a celestial body classified as a long-period radio transient. The peculiarity is as follows. It emits not only in the radio range, but also in the X-ray range, which is absolutely uncharacteristic for such objects. The pulses are synchronized and last for 120 seconds each, with an interval of 44 minutes. The LPT data is located in the Milky Way, 15,000 light-years away from us. Unfortunately, the area where it's located is filled with dust and gases, which makes visual observation much more difficult. Most likely, it's a fairly compact object about 20 kilometers in diameter, as indicated by its X-ray characteristics. Which telescope discovered the mysterious celestial body by name? It is clear that it was Australian Square Kilometre Array Pathfinder, a ground-based radio observatory located in Western Australia. By the way, about a year after the initial discovery, in February 2024, the Chandra telescope also detected X-ray pulses in this region of the sky. Two major organizations immediately took up the research: the International Center for Radio Astronomy Research and Curtin University. The results of the brainstorming session were published in the journal Nature in the May 28, 2021 issue. What other oddities does ASCAR J1832-0911 exhibit? First, it changes brightness significantly. In December 2023 and during the winter of 2024, this parameter in the radio range exceeded that of most observed stars by 10,000 times. And after this outburst, both the radio and X-ray emissions dropped sharply by 3 orders of magnitude. This is inexplicably unusual behavior and a very strange instability. In any case, this is the first time something like this has been observed in the Milky Way. So, what do astronomers think we are dealing with? It is possible that here too, we are receiving a signal from an alien civilization, one that is technologically hundreds of times more advanced than ours. Some media outlets have indeed linked these pulses to technosignatures, but most scientists still refute such assumptions. So, what is this object, and why does it behave so strangely? There are several hypotheses. It could be a very old neutron star, since the activity of magnetars doesn't last more than 10 to 50,000 years. Astrophysicists were led to this version by the object's extremely strong magnetic field. However, there's a discrepancy with the timing. It should have weakened by now, but in reality, we don't observe this. In addition, magnetars, like pulsars, emit in very short periods and are much less bright. The second theory is a white dwarf from a binary star system supposedly magnetized by the second object, for example, a dwarf star. But even here, not everything is smooth. The behavior of American Society of Composers, Authors, and Publishers, J18,320,911, is not typical for members of such systems. Then maybe these are fragments of a supernova? The area where the object is located encourages such thoughts. Therefore, the third version remains, which states that we are dealing with an absolutely new, unexplored class of objects. The problem is that this may require a radical revision of cosmological models and will lead to the creation of new physics. We also shouldn't rule out the extraterrestrial origin of the pulsation. Both scientific theories and assumptions about technosignatures are equally unproven, so they have an equal right to exist. In any case, the search for intelligent life continues, and its methods are becoming more complex and diverse. In the 21st century, they are radically different from the Morse code that was sent into space in 1962, and by now, the signal has traveled 60 light-years away from Earth. The more thoroughly and thoughtfully we study the universe, the less we actually understand what is really happening around us. Have you noticed how spectacularly the theories we relied on as an unshakable foundation are collapsing? This not only surprises us, but also forces us to reflect. Telescopes have been actively exploring the surroundings of the Earth lately. At the forefront, James Webb has confidently stepped up with cutting-edge equipment and great motivation. Launched into an orbit located 1.6 million kilometers from Earth. In December 2021, the device revealed a lot to the world. For example, it discovered the oldest black hole, which is about 13 billion years old, and several million times more massive than the Sun. This caused a bit of chaos among scientists, since the discovery undermines our understanding of how such objects form. The second challenge from James Webb to the astronomical community was the discovery of a group of rogue planets, which are considered failed stars. The telescope found them in the embrace of a distant nebula. These gas giants, 10 times more massive than Jupiter, currently do not belong to any star system. They are simply drifting through space with no known destination. Like samurai who have only the path where these outcasts were thrown from and where they are heading remains unknown. There are no answers to these questions yet. But the final blow was the discovery of a galaxy that was born just 300 million years after the Big Bang, which is basically impossible if we trust fundamental cosmological theories. Maybe it's a mistake? Not at all. After its launch, the James Webb Infrared Telescope, packed with modern equipment, began actively discovering distant galaxies. But this time, it outdid itself. The galaxy JATES GSZ14-0 is currently the most distant ever discovered in the history of astronomy. It appeared, by the standards of the universe, in the very first moments after the Big Bang. But then the question arises, why is it so mature, has a complex structure, and contains a significant number of stars? It turns out that we know absolutely nothing about the past of the universe. And all this time we've been deceiving ourselves with some far-fetched theories. Let's clarify one more point. What exactly did astronomers expect to see in this area? This question is easy to answer. According to the traditional theory, astronomers were supposed to observe the Dark Ages, when the period of a homogeneous hot universe ended and a long stage of cold, dark matter began. But James Webb found not only fully formed stars, but entire galaxies, some with central black holes. So should we cancel the Big Bang theory and shame it? It's not that simple to do. The thing is, its existence is confirmed by a lot of very precise observations, including the fact that it explains the chemical composition of the universe. If the theory changes, it will just be in details, since there's no alternative to the Big Bang and none expected soon. What should we do with the discovered galaxy, and how should we interpret its discovery? James Webb detected it using a spectrograph, and it turned out that the object is much brighter and more massive than what was expected to be found here. Unfortunately, it was not possible to determine the size of the galaxy, but its luminosity parameters are extremely high. Spectroscopic analysis also revealed sporadic emissions of ionized hydrogen and oxygen. Will scientists try to explain these paradoxes? Regarding ancient black holes, there are already some explanations. Some astronomers believe that old black holes, which they call primary as opposed to secondary ones, appeared, so to speak, by default. Some regions of the universe didn't expand with the rest of space. This occurred at certain points where matter stayed super dense and appeared to freeze in place. This is exactly how astronomers describe the state of primary black holes and explain their appearance almost immediately after the Big Bang. The hypothesis isn't mathematically confirmed yet, but discussions continue. What other feature attracted astronomers' attention to the ancient galaxy JADES GSZ14-0 studies have shown that it is quite sparse. From this, it can be concluded that the galaxy most likely does not have an active core, and its brightness is explained by the presence of a large number of stars. That is, the object can be considered a good candidate for studying the process of rapid galaxy formation by explosion. By the way, the maturity of the cluster was also indicated by oxygen. At the very beginning of the formation of the universe, there were light molecules present in space, and oxygen was not among them. But in the galaxy that James Webb found, this element was detected. In general, discovering such an unexpected find in this cosmic wilderness can be compared to going to a kindergarten expecting to see little kids, but instead finding the entire faculty of the philosophy department there. But despite the obvious advantages after James Webb was launched into orbit, there's often been a critical attitude toward this project. Some astronomers think that so much money could have been spent more wisely and used better. Remember, building the telescope and launching the mission cost $10 billion, not counting operations. Many are convinced that the project is actually covering up completely different objectives, masking real research related to military technologies. Greetings from the conspiracy theorists. Specialists from the Massachusetts Institute of Technology are more specific in their statements. They say James Webb isn't ideal for exoplanet searches and mainly takes spectacular photos. The criticism concerns the data analysis model installed in the telescope's firmware. The following astronomers believe that it needs to be radically changed to achieve more accurate results. Be that as it may, the scientific research conducted by the orbital telescope is quite significant. In that year, the observatory captured the collision of two galaxies. The event took place in the constellation Leo Minor, which is located 465 million light-years from the Sun. The near and mid-infrared ranges were used during the discovery. How were scientists able to determine that a collision had occurred? First, both galaxies are connected by a distinct star-gas tidal tail. Second, one of the clusters has severely distorted spiral arms. Later, after hundreds of millions of years, they will gradually merge, similar to how the Milky Way will one day merge with Andromeda, forming a new giant galaxy called Milkomeda. Let's discuss another discovery by James Webb. 13 billion light-years away from us, there's a galaxy called Rubeus UDS QGZ7, and it's dead. This object died young. Galaxies can fade away so early, almost right after their birth. Formerly, it was called a massive quiescent galaxy. The concept of death for such clusters includes a slowdown or even a complete halt of star formation. This stops the development of such an object and leads to its gradual fading. In Rubeus UDS QGZ7, the total mass of stars is about 15 billion suns. It is filled with relatively small and ancient stars with a red glow. Through the lenses of James Webb, such objects appear as bright red dots around the Milky Way. There are plenty of dead galaxies, but this doesn't surprise scientists since these objects had plenty of time to burn out. But such ancient star clusters don't have that right, or the capability, because just for a single star to appear takes millions of years, not to mention the formation of entire galaxies. Moreover, Rubeus UDS QGZ7 stopped forming stars 100 million years before it was observed by James Webb. What conclusions did astrophysicists make? There are no definite results yet. The only thing is, experts have statistically calculated that such galaxies occur in the universe no more than 1 in a million. So, in the end, is James Webb useful for science, or is it just a cover for some kind of shadowy research? At the moment, the orbital telescope is demonstrating unprecedented efficiency, opening up new scientific horizons and forcing scientists to reconsider old theories and develop more relevant ones. Although it's a hassle, it's quite productive in terms of advancing progress. The telescope's future goals are ambitious and extensive. To describe the reionization era after the Dark Ages, to discover as many cold exoplanets as possible, whose surface temperatures are almost equal to Earth's, and also to try to find water worlds like Europa or Enceladus. There are many plans, and they won't be implemented for a very long time because the official start of the observatory's scientific work took place relatively recently, on July 12, 2022. Let's not be critical, but simply enjoy the anticipation of new discoveries. Until quite recently, the scientific community, like ordinary people, believed that interstellar space was absolutely silent, and you definitely wouldn't hear a single sound there. But during recent space missions, it turned out that this is far from the case. Just listen to the sounds that Voyager 1 recorded in space. How could it have appeared in a place where no life has been found? These are far from all the discoveries we've made during the Voyager mission. Before that, Voyager 2 discovered information that forced scientists to reconsider the established data about the density of interstellar space. The circumstances turned out in such a way that we were able to learn about this only now. What exactly are Voyager 1 and Voyager 2? What is the difference between them? And which Voyager turned out to be more useful for world science? The original mission of these spacecraft was to study the 4 largest planets in our system, namely Neptune, Uranus, Saturn, and Jupiter. According to National Aeronautics and Space Administration scientists, in the second half of the 20th century, these celestial bodies were expected to be positioned in such a way that gravity would help increase the speed of Voyager. If they had been launched either too early or too late, the mission could have been considered a failure. It was important not to miss the right moment because the planets would be in the same position only after 176 years. If the mission had failed, we wouldn't have recordings of space noises or unique photos of the giant planets today. So, what were the differences between the two spacecraft? In terms of specifications, they are absolutely identical. 2.5 meters in length, weighing almost 800 kilograms, 16 thrusters, and a memory unit with a capacity of 67 megabytes. You probably have a question. Since the Voyagers are basically no different from each other, why do they differ so much in terms of effectiveness? The mission began at Cape Canaveral in Florida in the summer of 1977, when scientists launched Voyager 2 into space. His brother and twin were sent 16 days later. Since then, both spacecraft have been exploring space, and the difference in launch times put Voyager 1 and Voyager 2 in different conditions. So how did both spacecraft operate in space? Although Voyager 2 had been in space longer than Voyager 1, it was the latter that initially had more advantages. This was because the spacecraft performed gravitational maneuvers, allowing it to reach Jupiter several months earlier than its twin. In the spring of 1979, Voyager 1 added to its list of achievements by collecting data on 2 previously unknown moons of Jupiter and capturing images of volcanic activity on another of the giant planet's moons, Voyager 2. Voyager 2 was also busy, trying to catch up with the other spacecraft. This paid off, and soon data appeared about a new moon of Jupiter, Adrastea, as well as the first images of the planet's rings related to the moon. It's located in one of Jupiter's rings, and it's impossible to detect it while observing from Earth. If it weren't for Voyager 2, we might never have learned about Adrastea. How did things go with Voyager 1? In the early 80s, it provided images of Saturn and data about its new moons, Pandora, Atlas, and Prometheus. As soon as the information was processed on Earth, Voyager 1 changed its course and headed beyond our solar system. 9 months later, Voyager 2 also reached Saturn and took pictures of the planet. After that, the spacecraft reached Uranus and took pictures of it, gathering information about its temperature conditions. Thus, we learned that Uranus can be classified as the planet with the lowest temperatures in the solar system, namely almost 60 kelvins, which is minus 204 degrees Celsius. Voyager 2 didn't stop there, and just 3 years later it photographed Neptune and recorded storm activity in the southern part. The spacecraft became the only device that managed to explore 4 planets in our system. In this, Voyager 2 surpassed its twin brother. After exploring Neptune, it shut down its recording devices and set off to study the space between the stars. Let's get back to Voyager. It also had to shut down its recording devices, but before that, it was 6 billion kilometers away from the Sun. On February 14, 1990, it took a picture of the solar system, known as the family portrait, and one of the most popular and incredible photos was called the pale blue dot, which shows our planet Earth. So both Voyagers left the solar system. What awaited them beyond its boundaries? Voyager 1 broke another record by becoming the most distant human-made spacecraft from Earth. Let's add to that a record-breaking speed of 17 kilometers per second. With these characteristics, Voyager 1 flew through the region of solar winds and ended up directly in interstellar space. But Voyager 2 in 2012 earned the title of the spacecraft that has been on a space mission the longest since 1977. In 2018, the most interesting part began. As soon as Voyager 2 entered the space between the stars, it instantly detected something inexplicable. Since our school days, we were told that space is absolutely silent, that it's a vacuum zone, but it turned out to be different. The thing is, the density of solar winds is about 10 particles per cubic centimeter, but when crossing the edge of the solar system, the density is already 2,000 electrons. However, when Voyager 2 was already at a considerable distance from the Sun, almost 19 billion kilometers away, the sensors recorded an increase in density up to 0.12 electrons. Right now, scientists are not ready to name the specific reasons for this phenomenon, but with new data in the future, the situation could change dramatically. Let's pay a little more attention to Voyager 1, especially since its discoveries are no less interesting. Listen to this sound. This is how plasma vibrates, which is most commonly found in outer space and is a component of stars. Such plasma appears when the plasma from the Sun collides with the space between the stars. There's nothing extraordinary about this. But 4 years ago, in 2017, the instruments on Voyager 1 detected a weak, only 3 kilohertz, but continuous signal in space. It lasted for about 3 years, and during all that time, Voyager 1 was moving farther away, increasing the distance, but the frequency of the signal remained the same. It's already been 44 years since Voyager began its space mission, so what happens next? The spacecraft can no longer return to Earth. In 40 years, Voyager 1 will pass very close to star 245, which is located in the constellation Camelopardalis, and it will continue to travel through the Milky Way. His twin brother, in addition to encountering a cluster of comets near the solar system, will, after the same amount of time, fly near the constellation Andromeda and the star Ross 248, and then move towards Sirius and Canis Major. It's sad to realize that we definitely won't live to see that. When Voyager runs out of fuel, they will still be able to travel through the universe, but they will no longer be able to send data back to Earth. Starting from 2034, we won't be able to learn anything more about Voyager 2, and from 2040 about Voyager 1. That's the story. So, which of the spacecraft turned out to be more successful? You can't really say that Voyager 1 or Voyager 2 is better. Each turned out to be useful in its own way. For example, Voyager 1 was the fastest, while Voyager 2 was the most hard-working. Which spacecraft's work did you like more? Have you ever wondered what happens in places where no human has ever set foot, like on another planet? Let's not take the obvious Mars, which has already been talked about a lot, but Jupiter, the largest planet, the gas giant of the solar system. Let's board our imaginary spaceship and set off for this amazing planet. A real journey would take about 5 years. But we'll learn about Jupiter's secrets in just a few seconds. But before we begin, answer one question. Why do you think this planet is called a gas giant? It's simple. If you reach Jupiter, you won't be able to walk on its surface like you would on any other planet in our solar system. The thing is, its atmosphere is made up only of helium and hydrogen, so Jupiter's outer layer isn't solid like Earth's, for example, and it feels more like a cloud. That's actually cool. We could just fly a rocket right through Jupiter. You might think that's pretty logical, but in reality, it's not like that at all. Now let's get back to our high-speed journey to the gas planet. Here you are, flying on a state-of-the-art spaceship, amazed at how enormous Jupiter is. By the way, if it weren't a planet but just a round-shaped box, it could easily fit more than 1,000 Earths inside. That's not the only thing that amazes our minds. Take a closer look at the surface of this giant, and you'll surely notice 7 huge ovals. These are powerful vortices that stand out with their bright white color. But that's not everything. Now take a look at the well-known red spot, which is about 12 to 14,000 kilometers wide. This is a powerful hurricane, considered the strongest in the solar system. Of course, we'll try to stay away from it. And now we're reaching Jupiter's atmosphere. The spacecraft is shaking because we have to move at very high speeds. We're only in the upper layers right now, but the heat is already unbearable. The temperature is over 700 degrees Celsius. But let's imagine that our vessel is high-tech and fully protected from high temperatures, so we keep moving forward. That's not the only problem we're going to face. Jupiter's rotation speed around its axis is very high, in kilometers per hour, so a day here lasts half as long as it does on Earth. Even the most powerful hurricanes don't move across our planet at such speeds. Sudden intense heat is replaced by cold, with a sharp drop in temperature down to minus 73 degrees, while at the same time, atmospheric pressure increases. With such adventures, we completely cross the upper layers of Jupiter's atmosphere, its stratosphere. Further on, the deeper we go, the higher the temperature, wind speed, and atmospheric pressure will become. Now look at what's happening around you. You see lightning of incredible size and dense layers of clouds made of ammonia. Are you curious about what will happen next? We need to find out as soon as possible, but wait, we can't do that. You're probably wondering why scientists haven't yet discovered what lies beyond the ammonia clouds. 1,162 kilometers, remained the maximum distance that space probes were able to reach. They couldn't go any further because the increasing pressure caused them to break down, and eventually they were completely destroyed. One of these was a probe called Galileo. It managed to last almost an hour in such harsh conditions on Jupiter, and that was already a huge achievement. What about our imaginary spaceship? Let's imagine that technology has advanced a lot in recent years, and now our vessel is no longer threatened by things like high pressure. And here we are, despite all the difficulties flying further. We've already covered 5,000 kilometers, and if we want to go back, it will be a problem. Our ship is approaching one of the most mysterious objects in the solar system, the core of Jupiter. Here, the temperatures reach some unreal numbers, 4,013 degrees. We definitely wouldn't survive in such conditions, but as we remember, our spaceship is high-tech, which means it should withstand even these temperatures. We can hardly see anything, so we have to rely only on our senses. Now, all means of communication with Earth have stopped working. We can't send any signals anymore, but our spaceship keeps moving forward to a place where, in reality, it's unlikely that any spacecraft would ever end up. Despite the poor visibility, we notice a huge ocean with some strange substance bubbling in it. It is located at a depth of 19,500 kilometers and is considered one of Jupiter's layers. Even the best researchers in the world can't say how everything is arranged here. Near the core, the temperature is even higher than on the Sun, and the atmospheric pressure is 2 million times greater than on Earth. These are very difficult conditions, because of which the hydrogen in Jupiter's atmosphere begins to change its characteristics. So-called metallic hydrogen is formed because the distance between the molecules is reduced to a minimum. At the same time, in its normal state, hydrogen has the lowest weight of all the elements. And as a result of these metamorphoses, on Jupiter it becomes similar in its properties to a metal. It's not possible to get a better look at what the ocean is like because metallic hydrogen can reflect more than 90% of light. Even if you use light sources, you still won't see anything because of the incredible reflectivity of this form of hydrogen. And what is happening to our spaceship? It's as if it's stuck in one place and can't move forward. Gravity and the repulsive force coming from metallic hydrogen have collided with each other. That's why it seems from the outside that the space object is moving forward, but at the same time it's being pushed back. For a while, our ship can still move forward a little bit, but after that, it can only drift freely. In fact, at the center of a giant planet, this is a serious obstacle. But what's behind it? The core of a gas planet? There is still no consensus about its characteristics and structure. Scientists have different theories. Some claim that it is a molten body with high temperatures, while others say that, on the contrary, it is a solid object that is much larger than our planet. This core has a rocky terrain, and metallic hydrogen accumulates around it, forming a dense layer with ordinary hydrogen located above it. The properties of such a core are unknown, but one thing scientists assume is that it's about 35,000 degrees. Just think about it, everything around would instantly melt from that. As you can imagine, our spaceship wouldn't be able to fly through Jupiter. We would face many obstacles, from metallic hydrogen to the planet's core. And don't forget about the changes in pressure and temperature that would accompany you during the journey. Oh, right, we almost forgot to mention the radiation in the Great Red Spot. All of this creates a true path of death, which is simply impossible to overcome at the moment. It's better to let spacecraft explore Jupiter, not people. There has been some progress in this area. In 2016, the Juno probe is working on studying the planet, It has already taken pictures of the most beautiful aurora, which is the largest in the entire solar system, and recorded the sounds of a shock wave. Be that as it may, Jupiter still holds many secrets and is not planning to reveal them yet. And what do you think? Will technology ever advance enough to fully study this planet?